Hi guys, this is Sebastian from Madrigal, and welcome back to another hyper development video. So last time we cut the video a little short because I had to do a little bit of research into how arrays are to be passed between C++ and Zig, and also even just how arrays are to be passed into methods in Zig. Seeing as I'm very much a Zig noob myself, this was not immediately obvious to me. But I have figured that out, at least for the time being, so that we can continue with our navmesh stuff. Essentially, we are now starting where we left off last time, except I have implemented this findPath function in the navmesh runtime, and we can now test to see if it's working. Another thing I did since last time is I actually introduced this navmesh ID on the Zig side as well. I figured why not, this is an easy thing to do. So our has navmesh has now received this navmesh ID as well, and we just cast it to an int and call the C++ side the same way as before. Okay, so there are some things perhaps to discuss here in the binding of findPath. I'm not 100% sure that everything I've done here is makes sense, but I think this is what I'm gonna start with. So first of all, one small binding detail that may not be immediately obvious. We use these vectories in Zig, and these are just a regular Zig struct x, y, and z, and this has methods and or member functions, whatever they're called in Zig. And this is what I want to use for all the gameplay code. But when we actually pass vec3s to the C++ side, I actually don't use these vec3s. It's a little unclear to me currently if I could just do that, but I don't do that currently. Instead, I use something called an interrupt vec3, which is actually a C struct. And as I mentioned previously, Zig actually reads C headers, so we can look at this basic Zig interrupt types here. I have a bunch of types that are just plain C structs, and here for example, we have the interrupt vec3. The reason why I'm doing this is that this seems to be the most compatible way of passing data between C and Zig, just using regular C structs, especially when it comes to like arrays and lists of things. This may not be the case currently, but I find this works very well across both Windows and Mac, and so that's why I'm using these types rather than the Zig types, even though it might work nowadays. I'm not sure. And this becomes an issue when we have this findPath function now. So let's say what it actually takes. So we have the ID, we have the start point, end point, and then we have this path array here. And this is what is called a slice in Zig. So it is essentially like a view into an array of some size. A slice can be essentially representing the whole array, or it can be just a part of the array. And these are just the native Zig vec3s. So what I essentially want to do here is create another buffer of these interrupt vec3s that I pass to the C++ side, and then when I get the results back, I actually cast them into this from the path buffer back into the path array, which is what this loop here is doing. And we can get the length of the slice, which essentially tells us how big is the vector that is backing this slice. And based on that, we could allocate some like dynamic buffer to make sure it's the same size. I don't actually want to do that because we might want to run these find path queries quite often, and if we were to allocate dynamic memory every time, it's actually kind of heavy, and paths don't tend to be that long anyway. So what I've opted to do here is I have this max array size of 32, and the system just cuts off at 32. So if you pass like a longer slice in here, it would actually just use the first 32 points, and then write them back to the array when it's done. So what that means is that with this system we currently can't get paths longer than 32 points on the nav mesh, but that essentially never happens anyway. Like a path of 32 points is considered to be very, very long. So and I can up this later if I want to. But this way we just create the path buffer here on the stack, so we don't have to allocate any extra memory or anything like that. Yes, and then we call the C++ side, cast the enum to an int, and give it the parameters, and then we get the result back, and we cast that int back to an enum, which is this result here. And if we are successful, then, as I said, we store the array in this slice. Right, so let's see if this works. And what I was thinking is that if we look at the game, what we have here now, we can even zoom out the camera a little bit. So we have these guys spawning close to us, and it should spawn 10 of them, and then keep that 10 enemies. So what we would want to do in our actual game is that these guys would now start moving toward our player. I don't think they need to take each other into account, like they don't need to consider each other when moving towards me, but they need to consider these obstacles. So essentially what I want to do is have it so that when I move around here, these guys will follow me. That's the next thing we should do. So in order to do that, they each need to periodically figure out a path from themselves to me. So this guy, for example, would go like this, or the other way around like this. So let's try to do that next. And before we actually do any moving, let's just draw the path that the enemy has found, and start with that. Okay, so how do we do that then? I think the most natural place to put this kind of logic would be here in the enemy component function. So how do we actually do it? Well, let's say that the enemy wants to run a new path query every second. Essentially, every second the enemy tries to figure out where the player is and move towards them. Now, luckily we actually have this message already sent, where the player essentially, or each player, shall we say, if this turns out to be a multiplayer game, each player sort of advertises where they are. So we can use this in the enemy component as well. So let's do that. We can just copy this on message received and put it in our public function section, and we can get rid of everything except that one message that we're interested in. And the other thing we need to do is make sure that the enemy component subscribes to the category of that message. Yeah, we can just do it here, like this. So essentially the only thing we want to do right now is just store the position of the player. And if this is to work as a multiplayer game, each enemy would essentially need to store the position of all the players. Currently we don't do any multiplayer stuff, so maybe we don't need to care about that right now. And we can just, actually before I do anything, let's add the Vec3 here, so basis math, Vec3, and oh, what? Okay. This is actually another computer than the one I recorded the previous video on, so I hope everything works out fine, but we'll see. Anyway, so let's call this play, again call this last known player position, just like we did in the game master, and I think that was 0, something like that. Unused local constant. Okay, that's fine. We're gonna use it right now. So host ID, let's actually just assign that to the unused constant, and then make self dot last known position, and that should be fine. Cool. All right, so now the enemy knows where the player is, and we can kind of use the similar way of doing the timing the queries as we did with the spawn enemy spawns. So let's do time between path queries. And that's supposed to be an F32, and it's supposed to be, let's say, 1 second. Oh, yeah. Yeah, this kind of throws me off. Like when you're setting up a member variable, you're supposed to use comma, but then when you do constants, you're supposed to use semicolon. Okay. And time since path query, and that's also an F32. And actually, I think I found what I was looking for earlier. Okay, well, yeah. Here you can see my fear come to pass with my standard library not showing up properly. But if we go to math here, so there's the Zig standard library, you can actually see they have constants here for F32 max, and this is essentially what I was looking for earlier when I was like, okay, we want a very large value. So this would be like std math F32 max. I think that's how you're supposed to use it, and let's use it there as well, and see if this builds. Yes. Okay. So we want to initialize it to a very large value, so that at the first opportunity the enemy will get to do a query towards the player. And I usually do something like this. I kind of organize these into sections like this. Okay. All right. So we know the position of ourselves, and with we, I mean the enemy. The enemy knows its own position, and it now knows the last known player position. Or it will as soon as the first message has arrived. So essentially that's all we need to do the query, but let's store a few things. So let's go back to navmesh runtime. Let's put it over there and see what we have. So start point, end point. We need an array to store the path, we need a length of that path, and then search box size. We can just, I think 10 is the default on the C++ side, so that's what we're going to use. So right, let's do path. What do we call it? Movement path or something. Movement path. And we could actually probably put in a constant here as well. Const movement path max length or something like that, and let's make it the 32 so that we have the same size as the system supports currently, and that would be Vec3, and this I think we need to set to undefined like this. Let's make sure I have the syntax correct. I do, yes. Okay, so this is an array of Vec3s of size 32, and it's initialized to undefined. We don't know like what those are yet. The next thing we need to do is the movement path length, and that it's supposed to be an unsigned int, and we can initialize it to 0. If we don't initialize these here, we need to do it here in the init function when we actually return ourselves. Otherwise, Zig is going to be unhappy. Okay, and I think that's all we need to do. So let's just quickly think about what we want to do with that path once we have it. So as the very first thing we want to do, we actually just want to render out the path, want to draw it. And there's this debug draw system that can be used for this kind of thing. Usually when I render a path, I do like a sphere at each point, and then just a line between the points. So we have functions for both of those already. So that works fine. And we can import that, or not import it, but make it a little easier to use. We're just doing debug draw equals basis.debug draw, I think, like that. And where do we want to draw it? Well, we essentially only have one place where we can use this if we want it to show up all the time, and that is the update method. So I think this has an update, for example, one of these guys. Yes. So this test component actually kind of handily demonstrates all of these system methods or functions, whatever you want to call them, these things that get called automatically if they exist in the class. So we have create, destroy, onParent created. Create is called when the component is created itself, and destroy when it's destroyed. OnParent created is called whenever all the components of the parent object is or are set up so that you can, for example, get pointers to siblings if you need to do that. Update is called every update. So essentially on the client it is called every frame, and on the server it is called every update, which is kind of, it seems a little weird that you would want to do that, but it will become clear later what it means that the server is updating. Then you have pre-tick and tick, and these are fixed update steps. So the game is currently set, for example, to tick at 60 Hertz, which means that it will be running this tick function 60 times per second. And pre-tick is exactly the same, except it is called before the physics simulation, and tick is called after the physics simulation. And we could call debug draw from a tick function here, but only if the game is actually rendering at 60 Hertz or whatever the tick rate is. And if it's not, then these would kind of not look correct. They might flicker or like blink in and out of existence because we're not calling it at the same rate as the renderer. And update, on the other hand, is the perfect place to do that. So let's just add this guy right here. And as you can see, I've done some tests in the test component previously with stuff like this. So we can actually, I'll just leave that there for now. Actually, why don't we actually just write this out now that we're doing this stuff. So if we have the movement path and we have the movement path length, we want to draw a sphere at every point, and then lines between those points. So let's do like var I 32 is 0, and then while I is less than self dot movement path length. What does the while loop look like? It looks a little different than in C. I actually have one here. Right, so it has this increment part here. And then we can just do debug draw sphere at self movement path I, and yeah, the radius is supposed to be pretty small. Let's do that, and then basis color. What do we call it? Well, what do we use? Let's just use white, like that, and then we have the lines. So it takes 2 points and a color. So yeah, we need to reset I and then just do. So we need to do one less, and then draw line 3D. I think it is. Yes. There, and to the next one, like that, and maybe this can be, I don't know, yellow or something. Make it look nice. And we don't use the delta time, but we do use self, so we can just get rid of that. Okay, let's build that. Of course. Yeah. That's what you get for copy pasting. All right. So every update, we now draw whatever we have in the path. There's one more wrinkle in this whole rendering thing. So the enemy component is actually, it is created on both the client and the server currently. I think I need to drag this here to get it to alright, here we have more of this stuff because I've switched computers. 1 second and we'll get it sorted out. So it's hyper, and we call it hyper, and we use hyperdata, and that should be fine. All right, so if we look at the blueprint again, Oh, that's actually a little silly that we have the enemy inside like a player blueprint file, but we can move it later. That's not a problem. So the enemy component here is created both on the client and the server. And it goes without saying that you can't really render things on the server, because the server might be sitting on a computer on another side of the planet. But you can actually call debug draw functions in single player scenarios, as long as you're certain that you're on the same machine as the client. However, the client and the server by default run on different threads, and debug draw has checks in place to make sure that you're not trying to call it from the wrong thread. So what we actually need to do here is enable this this flag here, which says that we don't create a server thread. Instead, we run the server on the same thread as the client. So if you're running things on the server and you want to draw, it only works if you're on the same process as a client, and it only works if you run the client on the same thread as the server. So now we should be fine. But this is stuff that we will probably remove immediately when we have the movement in place, because it won't work in the future if we're running on a different thread or indeed in multiplayer. And another thing to maybe mention here is that the AI is supposed to be a client-only thing in this game engine. Like that's how it's set up, and for example, the nav mesh doesn't really get loaded on the client anyway, since it is kind of global data, and you can just call, has nav mesh. It might return true if you are on the same machine as the server, but you're not supposed to rely on it. So you're essentially only supposed to use the nav mesh on the server, and that's why we probably want to do something like this: self on context on server, and wrap this in it. There we go, and probably this as well, except it only sends it if it's on the server, so this thing won't be received ever on the client currently. That's just something to keep in mind. Okay, so now that we have the drawing sorted out, we can start tackling the actual querying of the path. And the querying of the path is something that we probably don't want to put in update, because update is called every update of the application, even though the game might be paused. So you're not really supposed to put anything in update that you want to have paused, if that makes sense. For that kind of stuff, you are supposed to use the tick function instead. So let's get that. We'll get one of those two and use that instead. And this tick function will stop being called if the game is paused for one reason or another. And we will actually use both of those, so we can remove those. Okay, so self.time since path query gets incremented with the tick time delta, which in this case will always be 1/60. And if time since path query has reached the time between path queries, then we set it back to 0, and then we we call find path to player or something like that, which we will now implement. So function, and let's just make that a void. It doesn't need to remove anything, return anything. It just writes to this movement path length and movement path member variables. We do need, however, this self guy here because it is a true member function. Okay, how do we actually call it then? Where's the runtime? Here's the runtime. So we need the ID, which is always main, start point, which is the current position, endpoint, which is the last known position. We need the array and the length, and that's it. Yes, cool. This indeed does return a result for us, which we could perhaps store here. And so, what was it called? It's right here. It's navmesh query result. So let's do like movement path result. And then have we actually imported that? No, we haven't done that. Maybe we don't need to do that, but it's not used in that many places. So we have basis, navmesh runtime, and then navmesh query result. Oh, and this probably needs to be initialized as well. So it actually did get kind of long. What do we use as the default value? I don't know. Okay, or something. Yeah, because if we don't actually store this anywhere, then Zig is gonna force us to assign it to like the unused constant. And why not just assign it here? We can check it later if we want to. Another thing I think that we should probably do is just reset this to 0 before we do the call, so that if it for some reason fails, it won't actually write to this, and then these won't show up. It won't show any out of date paths. Okay, so basis navmesh runtime and find path, and here we have the ID. Navmesh ID main. Maybe I should have actually assigned the navmesh runtime to something shorter. Anyway, then we have the start point, and that's self context transform get position, and then we have self dot last known player position, and then we have the movement path, and this now expects a slice, but this is not a slice. This is an array with a fixed length, so we need to turn it into a slice, and we can do it. I think that was the syntax that just takes it and turns the whole thing into a slice, or turns it into a slice that represents the whole array. And then we need the address of the movement path length, and then finally we need the search box size, which I think I'm gonna put here. That's supposed to be a float. Just put it there so that no, don't do that. That's again not that either. Let's do it like this. Does that work? Yeah, if you put the last comma there, and it will keep the vertical formatting of the call. Right. Yeah, this might have to be changed later. Let's just see. We need to have something there. Okay. Find path to player. I think that should be it, really. We have the same thing again. Yeah, I should really... Well, I should not copy-paste as much as I do, but... That's another thing. But yeah, they should really just be self, like I now use with the enemy components, like self. You declare the self here and then just use self everywhere. It makes it easier to do these things. Right, yeah. We need the self there. Okay. I think this should now actually work. Let's have a look. What happens? Well, that didn't work. That didn't work at all. And that's kind of interesting because it just kicked me out. Okay, so let's start with putting a few breakpoints here in the interrupt layer. No, that doesn't work. Yeah, I'm trying to figure out what I have done since it last worked. I think it's probably one of these guys. Let's just do a quick test. Okay. Yeah, so it's one of those guys doing something uncool. Oh. Yeah. Huh, interesting. It actually does show an error there in the log. I haven't seen that before. How do we actually catch that, and what makes it shut down the whole program? How interesting. I mean, this should be 0, right? So it shouldn't ever go there. But it still seems to do something bad. interesting. So while I is less than that, right, so I'm almost certain this is like an out of bounds access thing that causes the crash. Am I doing something stupid here? Ah, this might actually be it, right? That's an right. That's an unsigned. That's an unsigned integer. So this actually makes it do a wraparound. Okay, all right. Oh boy. So actually, we can just do it here. Skip this whole thing if it's 0. Ah. What? Is it and? Oh, yes, reload. Thank you. Yeah, I am bad at Zig, as you can see. How does logical operators work? Is it and? Oh, come on. And what? There's no and here, is there? And okay, the Boolean operator and okay. Yeah, I've done some fairly advanced Zig things with the whole binding system, but I haven't done a lot of really basic things. So I run into these problems every now and then. Okay. Right. Now that's looking pretty good. And would you look at that? They are actually following me. So the new guys make a silly query here to the origin of the world, because they immediately get their path queried, but they haven't received the player position yet. So that's a little stupid, but hey, this works. Now they actually know how to find me. And it's looking quite all right. Yeah, so as you can see now, like these paths are like 3, 4, maybe 5 points tops. So the 32 will just be like clearly enough, because the path count doesn't necessarily go up with the distance. The nav mesh system is smart enough to just return a long path if there's nothing in the way. Yeah, okay. Yeah, this looks good. Right. Okay, yeah. So what happened here was that when this guy was 0, and since it's an unsigned integer, when I did -1, this became like FFFFFFF, which is a very large number, and then this tried to access into that, which was only 32, and then it crashed. Okay. Yeah, that was stupid. So let's do one thing here. Let's see, why does why does the newly spawned make a query to origin? Like this is 0, so that makes sense, but this should be sent every tick to everyone. So it should almost immediately get updated with a proper value. And it's clearly not. Like you can see here in the beginning when the, if you move the camera out a little bit, even those guys that are placed in the level, they make the wrong query first, and then they find me. And everyone makes the wrong query first, and then they find me. So that's a bit weird. Why do they make the wrong query first? Last known player position. Almost as if this was sent at the same frequency as the path queries, but that's not the case, so yeah, it's a little weird. And this gets set here, and then it's used here. So if we put a breakpoint here, I can disable optimizations for this test, just so that we get the proper values in the debugger. There should be like an endpoint with 0, 0, 0 now. Or there shouldn't, but there probably is. Like, yeah, this is 0, 0, 0. Oh, right. Yeah, I know what the problem is. And you probably have figured it out way before me. Of course, like this gets updated all the time, but it has the 0 value in the beginning, and it immediately ticks because this is large, and then it does it with the 0, and it's almost immediately, so like on the next tick this is updated, but the path that we see is of course not updated until 1 second later. Okay, that's stupid. Let's do something like this. We init this to the max value. And that's essentially like our invalid player position, if you will. Maybe we can even do like invalid player position, and take that. I don't know, does that work? I think it should work. And then we init it to that, right? Does that build first of all? Yes, okay. And so here in the tick, we want to do an additional check. We want to do and self dot last known player position is not that, and I probably can't actually compare those because they're classes. Yeah, that's not great. we have Vectory is almost equal with, yeah, that should probably work. So let's actually just move this out here and do like const player position valid, and it is valid if we don't that's basis math Vectory is almost equal, and we do self dot last known player position and invalid player position, right? So it is valid if these are not equal or almost equal. Right. And that should fix it. So it holds off on running the first query until it has a valid player position. Let's see how that looks and or works. Yep, that looks better. So now the units, as they spawn in, they immediately start tracking toward me and not toward the world origin. Okay. All right, this is working quite nice now. And with this, we should actually be able to start adding movement next, because now they have a path that they can follow. They have a path that they can select the first point and start moving towards that, and then when they reach it, they select the next point, etc., until they run into me. And since I'm kind of going for like almost like a zombie type enemy with this base enemy, I think that's essentially all that we need to do. They don't need to take each other into account. And there is a way in the nav mesh system to add temporary obstacles that we haven't exposed to Zig yet. So that's something that we might want to do later in the game if we have more kind of intelligent enemies, so to speak. But for now, I think this actually will be everything that we need. But yes, I will end this video here, and we'll tackle the movement in the next one. So this is starting to look like something already. When we get movement and we get player weapons so that we can actually shoot those guys, then we kind of have the very basics for a twin stick shooter already in place. So cool stuff is happening. Thanks for watching. Leave comments, etc. You know the deal. And I'll see you next time. Bye.